Am I audible to everyone?
Yes.
Okay, so we can start this session. So, myself Yashvi Sheth. I am a research scholar at IIT Bombay. Let me share my screen and let me know whether it is visible to you. Can you see my screen now?
Yes.
Okay, so good evening everyone. Myself Yashvi, and I am a research scholar at IIT Bombay, and this is the live session for uh, the course Basic Environmental Engineering Pollution and Abatement, taught by Professor Prasenajit Mondal from IIT Roorkee. And this session will be mainly focused on the brief review or the uh, highlights of the lectures that have been taught by professor, and also we will be solving the assignments or the model assignment that we have, and that you can use for solving the actual assignment provided to you for this course. So should we start? So the live session for this course will be on every Tuesday 7 to 9, and the Google Meet link is already provided, and the session video will also be uploaded on my YouTube channel. So if you want to go to that, you can access the video there as well. So now let's start with the actual content, and firstly, like, my pattern would be, I will be starting with the brief of what has been taught, and in the later part I will be discussing the assignments, and you also can come up with any doubts if you have during the lectures, or any other doubt in the assignment. So now let's start with this. So in the first lecture, like, why do we study this course? Okay, so as we know that nowadays, like after industrialization, the population has grown very much, and due to industrialization there is a lot of emission in the environment in the form of solid waste, or in the form of liquid waste, or even gaseous waste. So this has increased various problems to the human beings. Like, all of us know, and now even like kids know, that global warming is happening, and like many such factors like acid rain is occurring. Like sometimes you face flood like situation, sometimes you face scarcity of water. So all this is because of there is some imbalance in the environment happening, and that is why we need to study, like, what is the basic fundamentals of the environment, how to tackle, like what are the problems nowadays faced, and what are the remedies, or what are the ways you will deal with those problems. So firstly, the first lecture has covered mainly the basics of environment, and all of you would have studied all this in, like, mainly school also. So if you say, then what is the environment? So environment is the any condition where we live. So if I'm living here, then all the surroundings, like it can be soil, water, air, all the living organisms around me, it comprise of the environment. So all everything around me will be included in the environment. You can stop me anywhere if you have any doubt in between as well, or you can drop in the chat box as well. So as I mentioned, I will just give me a second. I will just use the laser pointer. Yeah. So
యూ హ్యావ్ టు బెట్ ఇఫ్ నేను నెక్స్ట్ వేసే కార్డ్ ఈ రెండు మధ్యలో ఉంటుందా లేదా నువ్వు గెస్ చేయాలి.
Please mute yourself. Yeah, so the impacts on environment due to the increasing pollution. Can anyone tell me the reasons for like what has caused, like why is the increase in pollution responsible for the negative or adverse impacts on environment? Like I have listed down the cause or the impacts on the environment, but what are the main causes, like why increase in population has resulted into these? So please, anyone? So if not,
industrialization main.
Yeah, so like as the industrialization has increased and population has increased, the lifestyle of people has increased, so more and more we have to use the fossil fuel to meet with the demands of increasing population, because like you can say more electricity is required, so more you will extract the fossil fuel to convert it into the electricity. This is just one example, so this applies to each and everything, and that is why there will be a depletion of natural resources, like what we have observed. Just a second, I don't understand why it is not working well. So yeah, depletion of natural resources, deforestation, this all occurs due to meet with the increasing population, or to meet with the demands that are raised because of increasing population. So what has happened is the environment or the ecosystem or the earth has its own rate at which it can produce on its own, or it can produce naturally. So the consumption is nowadays much greater than what is generated. So that is why such situations have arisen. So to look into all this, we have started with this course. So basically what environment comprise of? Mainly atmosphere, which is nothing but air or the gaseous form, then water or the hydrosphere, it comprises of sea, ocean, etc. Lithosphere is related to the earth or the soil, and where all these are interconnected, and biosphere is where we live. Okay, so now all these components of the environment have been polluted, and there can be various ways to classify these waste. Like for example, if you drive a vehicle, like we always take a vehicle and go somewhere. So if you drive a vehicle, then there will be what will be used? Petrol. So petrol is obtained by various crude oil, and it will emit what? It will emit various carbon monoxide or carbon dioxide, SOx, NOx, etc., which will go into atmosphere. Also there will be some solid like dust like particles from vehicles also, that will be emitted into atmosphere. Now from industries there will be resulting wastewater, which will be after treatment or without treatment, it will be dumped into the water bodies, which will result into pollution. So mainly if we want to classify the waste, then it can be classified in various forms. Firstly, it can be hazardous or it can be non-hazardous. For example, non-hazardous, like whatever is biodegradable, it will pose less hazard. Okay, so one of the example is biodegradable. Okay, and hazardous waste are the ones which has negative impact on the environment. Now based on the phases, it can be classified into solid, like which we dump usually in landfill sites. Okay, we just dump as it is, then there will be liquid or water. Mainly liquid waste is in the form of wastewater, because water is the universal solvent, and we usually use water everywhere, and so the water gets contaminated by some external chemical agents which are not naturally available, or it goes above the concentration which is permissible. I just gave example of gaseous as well. So to minimize the hazards, what are the remedies or how we can stop it? So one of the ways is to reduce at its source. So how can we can anyone give me the example how can we reduce the pollution at source itself?
By treating the raw material at the initial stage.
Yeah, so
Ma'am, afforestation.
sorry.
Planting more trees, ma'am, afforestation.
Yeah, so the ways to do this is, for example, as some of you have correctly mentioned, we can treat raw material, or we can have afforestation, so that like as you have you must have listened that there is a rule passed to decrease the carbon dioxide emission in the environment, or to reduce the carbon dioxide in environment by the government. So to reduce the carbon dioxide, we can definitely increase the amount of forest coverage, which is afforestation. So these are some of the ways. Okay, another is we can use some alternative reaction method, or say for example, if I am using fossil fuel for generation of, or crude oil for coal for generation of electricity, then in that case I can replace some amount with by using renewable energy sources. Okay, so these are some of the ways, because like this should be the first priority, because we do not want any waste to generate itself. Okay, now next, if it is generated, then what to be done? Then we need to treat it, so that further it is not like, if we dump as it is, then more and more environment will get polluted. Okay, so we need to treat the waste stream so that further there is no pollution. So for that, one of the way is segregation at source. So you for example, if you have to treat, say for example, 50 liters and you have to treat 20 liters, so the amount of energy, amount of chemicals that are required for in both the case, like 20 liter is easier to treat as compared to 50 liters in terms of cost, in terms of chemicals required, everything. Okay, so it is always better to segregate. And also another way is to forecast, like what can be like, you would have seen many mock drills. Okay, so similarly we can forecast and we can plan, like what can be future, like in future what can happen, and based on that you can forecast what treatments or what precautions you need to take into account. So like moving forward, next is, in the second lecture we studied various basic definitions. Okay, so ecosystem, as you know, like we live in on this earth, and all the biotic and abiotic components, they combine together to form an ecosystem. Okay, so to the study of the interrelationships between the plants and animals which live in the ecosystem is known as ecology. Now this is very simple, so I will not go into deep. So species is the single, like homo sapien, so human being is the homo sapien species. So there will be lakhs or crores of species on earth. Now if the same species is living in the society, then it will be a population. Say for example, the population of tigers or the population of human beings. Now community forms when there will be more than one species. For example, deer, tiger, they live in the forest to form a community, and all together it is known as ecosystem. Now another terminology that was highlighted was food chain. Like all this community or ecosystem has like we get our food from the nature or from the environment, and all the species on the earth, they are interconnected in terms of their food requirement. So firstly, soil will provide the nutrients to the plant, and it will take up that nutrients in the presence of sunlight, okay, to grow. Like here it will be photosynthesis process. Now these plants will be consumed by herbivores, okay. So herbivores are nothing but the plant consuming species. Now these herbivores will be consumed by carnivores, and again on death this will be degraded by microorganisms, okay, and it will again go to soil. So this is all linked, and which is nothing but known as food chain. So this is how it is all interlinked. Next was various cycles were discussed, like biogeochemical cycles, which is nothing but water cycle, carbon cycle, nitrogen cycle, phosphorus cycle. You can let me know, like, do you want me to go in deep of all this, or should I just brief go to assignment? Because everything
If
has
possible, you can explain it in brief.
okay, I will explain in brief. So I guess this much brief is okay to everyone. Is this okay?
Screen is not visible.
Okay, yeah, I will share. Yeah, so coming to the biogeochemical cycle, wait. So first one is the water cycle. So you must be knowing that there will be reservoirs of water reservoirs, okay, in the form of lakes, ponds, rivers, ocean, okay. Now this water is in the liquid phase, and you must be having some idea of like this water which is present, it will have some tendency to interact with the air, okay. So there will be some evaporation of water from this water body, okay. This is evaporation. Now another terminology would be, if there are trees present, then there will be some droplets, or in the leaves also there will be some water content, okay. So that also, like if the leaves dried, then that water transferred to air is nothing but trans-evaporation, okay. So now this evaporation occurs if the temperature is rising, okay. So in summer season there will be rise in temperature, which will result in more and more evaporation of this water into air. Now this water vapor, they rise higher because water vapor has lower density. So lower density will rise high in the sky, where the temperature here in sky is very less, okay. So this will result into condensation of water vapor. Now this condensation will result into formation of tiny water droplets. When they become sufficiently heavy, they will fall on the earth in the form of rain, or it can even, like if the region is very cold, it can even fall in the form of snowfall. So this is how, like, water will transfer, like it will first evaporate and it will again come back to the same reservoir in the form of rain. So this is nothing but water cycle. Next, coming to the carbon cycle. So carbon cycle is nothing but you must be knowing that everything on earth is composed of carbon material, may it be plants, may it be our body, anything. Okay, so firstly there will be plants. Okay, these plants will be in the form of food chain. We consume plant, okay, by like, say for example, we consume plant, or human body is consumed by some carnivores, or there will be some death. So there will be degradation, and this degraded product will be again converted into carbon, which will go again into this soil. Now plants will, how will plants grow? They will consume the naturally available CO2, okay, to form their food. Like this will be sucrose, which is their food in the presence of sunlight. So now this will be consumed by herbivores, carnivores. Again they die, and that carbon is degraded, like it into back to carbon, and it again goes to soil. Now there will be externally how human has intervened in this cycle by producing more and more carbon dioxide by burning coal in the industries to form electricity. So this generates more and more carbon dioxide, which has been emitted in the environment, and it has created a somewhat imbalance in the system, like in the ecosystem or in the environment. Now next cycle is nitrogen cycle. So nitrogen is the basic element which is present in soil, because nitrogen is required in like we add fertilizer to the soil so that plant grows easily. So that nitrogen will be consumed by plant, and there will be some nitrification, denitrification process ongoing. So like nitrates will be formed, okay. So this such type of conversion, I don't exactly like write the reaction, but this reaction is occurring in the presence of microorganisms. And this again, so first nitrogen will be consumed, like consumed from the atmosphere. By nitrification it will be converted into nitrates by the microorganisms, and this again nitrates, it will be denitrification will occur, so that it goes into atmosphere. There will be some amount of nitrogen will be that will be consumed by plants, because they require nutrients, and one of those nutrients is nitrogen. Now this nitrogen again, it can leach out, okay, and it can go into the water bodies. And this water body also has, like there will be some algae growth, or there will be some seaweed, okay, there will be plants in water bodies as well. So that nitrogen will be consumed by the water bodies, in the water bodies, so that there will be growth of plants or some undesired algae as well in the water bodies. So this is how it is there for nitrogen. Now moving to phosphorus. So phosphorus in on the earth, it majorly like phosphorus is also one of the chemical or the chemical species which is consumed by plants for their growth, and we add pesticides as well. So phosphorus is consumed by plants, okay, and again phosphorus also leaches out to water, so that it it gets used up by plants for algae growth. Okay. Just a second. Yeah, again, once these plants are consumed and uh, the degradation occurs, this phosphorus comes back to the soil, and phosphorus rocks are produced over the period of time. So moving forward, let's let's go to the next terminology, that is the stable ecosystem. Okay, so these are all the cycles, and as I mentioned, due to the addition of carbon dioxide, due to the addition of pesticides, there is an imbalance of the natural content of carbon, nitrogen, phosphorus in the atmosphere. Okay, so this imbalance has already been observed. So stable ecosystem, one can say that the imbalance that has been created by us, it is still in the permissible limit, or the ecosystem or the earth is able to withstand that external stress of carbon dioxide, of the chemicals that are added into it. Okay, so this is the definition of stable ecosystem. Now moving forward, there will be some alterations in ecosystem, and for example, there will be global warming. Okay, so such like global warming, as you say, like there will be an increase in the average temperature of earth. Like, why is this happening? Because there is an increase in the amount of carbon dioxide or the greenhouse gases present in the environment, which stores the UV radiation or the amount of energy that is coming from sun. So that results into global warming. Also, if you say, then there will be emission of SOx, NOx in the environment. Okay, so now if these are emitted in the air, now then during the rain that occurs, this SOx and NOx, they partially react with water to form dilute acids. So this results into acid rain as well. So the alterations or the imbalance in ecosystem has been observed, and so what is required is to restore, like how we can restore the environment or the ecosystem. So for that, there will be some active or passive restoration. So passive restoration is nothing but earth has its own ability to restore. Like if you give years and years, like hundreds and hundreds of years, there will be again generation of the nutrients back in the soil, back in the earth. Okay, so that is nothing but passive restoration, but this takes long time, and we do not want to wait such. So there will be active restoration. So in that case, what we do, we externally add some nutrients or some like for example, if the soil is not suitable for agriculture, then what we do, we add organic pesticide, organic insect fertilizer to the soil, so that it is suitable again for the growth of plants. So this is nothing but the example of active restoration. Can you give another examples of the imbalance in the ecosystem that has been observed? Anyone? Yeah.
Increase in the sea water level.
Yeah, so that is also one of the imbalance. Another imbalance is climate change. You can see that there is a lot of like imbalance, and like there will be sometimes much rain, like flood conditions, or there will be sometimes drought. That is also imbalance. Another imbalance can be depletion in ozone layer. Okay, there will be the snow glaciers. So the area that has been covered, like that naturally covers the mountain regions by snow, that snow covered region has also reduced due to global warming. So all these are the adverse impacts on the ecosystem that has been observed. So now moving forward, so what do we need to do, and what pollutants are present in the ecosystem? So firstly, let's start with the ecosystem services. So earth, like what we are doing nowadays through industrialization is to increase our luxury for living. Okay, but earth has, or the ecosystem has, naturally provided us with the clean water, with food, with wood which is required for, let's say, if we want to create fire. Then there will be cool temperatures provided by trees. Then there will be natural purification systems are also there. Then carbon storage system is also there in the form of trees. So all this is like already there in the atmosphere or in the ecosystem, so that there is a balance. Now this imbalance is created in the ecosystem, and which is due to the continuous emission of various pollutants in soil, like in the lithosphere, in water, and in the air. Now if we take into account various water bodies, then what are the risks, and like what are the pollutants which are present, like dominant in water bodies? So you must have read in newspapers, or like it is very common that India is highly contaminated, especially West Bengal is contaminated with high concentrations of arsenic. Okay, so arsenic is one of the metalloid which is naturally present, and also such heavy metals like lead, cadmium, etc. So these are emitted in water bodies due to some improper treatment of water into the water bodies. Fluoride is also naturally present. So all these components, they pollute the water bodies. Now once it goes into the water bodies, as I mentioned, all the components on the earth, they are interlinked. Okay, so if it is present in water, now if this contaminated water is consumed by plants, okay, so such arsenic, fluoride, heavy metals or microbes, they will be consumed by plant also, which will hamper its growth, or the species, like there will be some adverse impact on plant can happen. Okay, now again this plant will be consumed by herbivores through food chain, and this herbivores will be consumed by carnivores. So this if once the water bodies or any component of ecosystem is contaminated, then through the food chain or the interlinked chain, it will pass on to the next level. Okay, so we can say that once it enters the environment, it will not move out. There will be a concentration or the bioconcentration of each of this in the organism. So bioconcentration is nothing but the process that results in an organism having higher concentration of that substance. So this concentration will increase in this organisms, and how much the organism is contaminated, that can be calculated through this factor. So this is nothing but what concentration of it is present in the organism as compared to what it is there in the environment. So bioaccumulation, as I mentioned, it transfers from one polluted stream through the food chain to each and every like plants, herbivores, carnivores, to entire ecosystem. Okay, so this is nothing but termed as accumulation of the pollutants in the environment or in the ecosystem. Now this depends on the rate of transfer, it depends on the mode of uptake, and it depends on how long it is exposed to that environment or to that substance. For example, if there will be microorganisms, so if the microbes or bacteria is present that can harm your health, and if bacteria is consumed by you through water, then the consumption through water, it is the mode of uptake. Now if you are consuming through water, then how long will it take, like how long will it take to take our body to naturally flush through urine. Okay, so this is how mode of uptake matters, and also how long you are exposed to it. Say for example, if you drink bacteria or microorganisms contaminated water once, then you might not feel weak, or you might not get disease. But if you take it for, let's say, 2 days continuously, then the duration increases, and that's how you can feel disease, you can have disease. Okay, so all these factors, they affect like whether it will be say for example result into some hazard or adverse impact or not. Now next term is biomagnification. So bioaccumulation of a substance of the food chain by transfer of residue of the substance in smaller organisms that are food for larger organisms in the chain. So it says that the species which is at the end has the higher risk of getting contaminated with that particular pollutant. Okay, so let's move forward. Next is in the fourth lecture, so the risk, so all this what we have covered so far is the imbalance in the ecosystem. Now this imbalance in the ecosystem has some adverse impact on living organisms and the quality of abiotic components. Okay, so now this risk is nothing but what is the probability of adverse outcome, and what adverse outcome that can happen is nothing but a hazard. Okay, it is nothing but a biological or chemical or physical agent that has potentially an adverse effect on maybe any living organism, not necessarily human beings, but any living organism. Okay, so risk you can define as it is a function of what is the hazardous impact. Okay, for example, there can be some bacteria which has less tendency to make you make you have disease, or there will be some microorganisms which will have more hazardous effect. Say for example, if you are like if you take water, and if you get typhoid containing bacteria or virus, then that will be normal fever. Now instead of that, if you get exposed to coronavirus, then obviously the hazard due to that is higher. So it depends on what pollutant is present. So the examples of hazard are as follows. Firstly, the human hazard can be in the form of carcinogenicity, which is nothing but cancer. Okay, so presence of any pollutant like heavy metals like lead, or any organic contaminants in water, they can cause cancer. Then there will be cardiotoxicity, which is nothing but related to heart. Okay, so if you take air which is highly polluted, then it can result into heart related problems. Then there can be neurotoxicity, or there can be even damage to the DNA or genes of your body. Another example is environmental hazard, which is nothing but the hazard to the aquatic system. Then there can be some physical hazard in, for example, there can be explosion, there can be change in the pH of water, there can be change in the dissolved oxygen content of water. So these are the example of physical hazard. And last is the global hazard, which I already mentioned as global warming, acid rain, water scarcity or flooding, the area coverage of snow, etc. So what we need to do is to have the analysis of what all risk can happen and what are the causes of it, and what are the expected consequences due to it, and if, like for example, if this hazard has already happened, then how will we manage, or how will we manage to avoid it. So first step is to identify the potential hazard. For example, if there is one unknown organic component in water, so if you need to know the hazard due to that organic component, then you need to find out what adverse impacts it can have. Then you analyze those impacts and what is the probability, and if that occurs, then how will you manage that. And there will be a community, or there will be various groups which will be dealing with all this, and they communicate with each other so that the risk can be minimized. Like there will be some guidelines posed by this community so that the risk can be minimized. So any hazard will be, like how much hazard will be occurring, it will depend on intensity, like how much amount is present. Okay, then it also depends on the frequency. As I mentioned, if you are consuming microorganism or bacteria contaminated water, then if you take just one glass of it, then there are chances that you might not feel like ill. Or if you take for 2 days, like that is nothing but the frequency of how you consume. So if the frequency increases, then obviously the chances of getting ill or adverse impacts will increase. Or how long you are taking. So these are nothing but few definitions that are very important. Now next is intake rate. So this is related to this. Okay, so exposure expressed as mass of that substance, which is nothing but the pollutant contacted per body weight, because any pollutant will have different impact. For example, if it is given to kid, or if it is given to an adult, then the same compound will have different impact on both of them. Okay, so this is nothing but we normalize it. So mass of the substance per unit body weight per unit time, okay, averaged over long period of time. So now so to check for the hazard which can occur, there are various tests. Okay, so what we do, there are
take a step back and act.
Sorry, hello.
It's a noise. It's a noise. Nothing.
Okay. Yeah, so there are various ways in identifying how, like what are the hazards, and what concentration the hazard is observed. So for that, what we do, if you want to find the hazard of any unknown material, then we first do lab trials. Okay, we inject various concentrations of that chemical to various, firstly small species, like that mimic human beings. For example, mice. Okay, so firstly we start with mice, then there can be monkeys, and there can be human. Okay, so these are the stages of trial, and we inject various concentrations of the component of which we need to find out the hazard. So So there will be a concentration till which you will not observe any hazardous effect. So that is nothing but this: no observed adverse effect level. And I guess it is correct, if I have not mistaken. Then there will be okay, so if this is the point till which you are not observing any change, okay, after certain time there will be the start at which the adverse effect starts. So that is, can you please mute yourself? So that is nothing but threshold at which it starts, and this is nothing but dose response curve. Like if further there is increase in the dosage or the intake of that pollutant, then what kind of hazard can occur to a particular species. Okay, so this is nothing but toxicity assessment. There is one more definition of lethal dose, which is nothing but if a certain compound or pollutant is given, then what is the concentration at which 50% of the community dies. So that is nothing but lethal concentration or lethal dosage. So now let's move forward with the assignment. So first question is, contaminated water can be purified by removing the following. So what could be the answer for this question? Anyone? Like,
All the above.
yeah.
All of these.
Yeah, okay, so just a second. So all of the above is the correct answer. Just a second, I need to plug in my laptop. Yeah, so all of these is the correct answer, and as I have mentioned, there can be biological contaminants which can cause the hazards by the presence of bacteria, fungus, virus, etc., and it can cause various infection in intestine, lungs, etc. So this is nothing but related to biological contaminants. Then heavy metals are, as I have mentioned, lead, mercury, cadmium, etc. Now if human is exposed to such high level of concentration, it can result into chronic toxicity to liver, kidney. It can cause cancer, and to like majorly all the parts of body can be affected due to it. And undesirable chemicals obviously we do not want. So all of the above is the correct answer. Moving forward, what is the health effect of excess fluoride in drinking water? Yeah, so can you tell me the mechanism for like what is fluorosis, and what is the permissible limit for the fluorine to be present in water? Okay, so I will tell. So fluorosis, like if the fluorine content is approximately 1.5 ppm in the drinking water, then this is the permissible limit. Okay, so this is the permissible limit, and this is set by WHO. Now this much fluorine is required for the dental and bone health. Like it results into, it protects teeth, and also it results into like promotes new bone formation. Now if it is present above that concentration, then again the teeth whitening and brown speckles are observed on teeth. That is why we restrict ourselves to this much dosage. So fluorosis is a kind of disease due to excessive fluoride. Next question is, find out the most suitable option from the following representing the dissolved oxygen content in natural water at normal pH. So can you give me the answer?
8 to 9 ppm.
Sorry?
8 to 9 ppm.
Yeah, so 8 to 9 ppm is the correct answer. So dissolved oxygen is required in the water bodies for the life of all the aquatic living organisms. So can you, like, I had given one example in the lecture itself, how there is transfer of gases, or how there is equilibrium established. So can someone tell me how the oxygen will be present in water, like what is the phenomena behind it? Anyone?
Algae present in water will it consume oxygen.
Yeah, actually water, see, water is in water there will be some oxygen which will be required for each and every aquatic bodies also, and algae will not like, so for respiration each and every living organism requires it, but it comes from the atmosphere. Okay, so atmosphere, as you know, it has, like, air has 21% O2 in it, which is in gaseous form. So now this O2 has some partial solubility in water, which will result into dissolution or some transfer of oxygen from gaseous phase to water bodies in the liquid phase. Okay, so this transfer occurs, and this is actually required so that the oxygen will be consumed by the um, organisms. Now on what factors does this depend? This will depend on the atmospheric pressure of oxygen and also the temperature of water, because one of the example is, like, the solubility depends on temperature. For example, if you have a bottle of cold drink, now if it is cool, then the carbon dioxide which is, like, resulting into that fizz, it will be highly like the soda will be very strong. Okay, now once you take it to room temperature, the fizz will be removed, like it will be, the amount of carbon dioxide will be less. So it will depend on temperature also, but at natural conditions this will be the answer. Now moving forward, which of the following does not contribute to the pollution of aquatic bodies? So this we have discussed many times, like heavy metal is one of the major pollutant. Microplastic and pesticide also pose pollution. However, ozone is the naturally occurring chemical in atmosphere. So if it is present in some concentration, then it will not cause pollution. Which of the following fuels cause minimum environmental pollution?
Hydrogen.
Yeah, so hydrogen is the correct answer, because sorry, as you know, nowadays the vehicles are also, like, there are rules getting formed to have hydrogen powered vehicles or hydrogen fuel cells to generate power. So, like, why do you want to switch to this? Because hydrogen will be minimum polluter, like it will still have some nitrogen, some carbon, so there will be some SOx NOx formation, there will be some carbon monoxide formation, but it will be minimum in the case of hydrogen. So next is which of the following is waterborne disease? So the answer is all the above. Yes, typhoid is observed due to water. If it is contaminated with bacteria or some organisms, then such water can cause typhoid. Cholera is also if we there is water contaminated or so, then cholera also can occur due to that, and diarrhea is one of the result of these two also. So all of the above is the answer. Next is which of the following is not a greenhouse gas found naturally in the atmosphere? So
Methane.
for sorry,
Methane, I
Nitrogen
guess.
oxide.
No, methane is naturally also produced. Yeah, nitrogen oxide is the correct answer because methane is naturally produced also. Like if there is some anaerobic digestion by the bacteria, then there will be formation of methane. So methane is a naturally occurring gas in the atmosphere. Ozone, as you know, there is a shield of ozone on the earth, like in the stratosphere, and carbon dioxide is also there. Now, nitrogen oxide is majorly formed due to the combustion process, like NOx in the form of NOx. So, that is the correct answer. Next is, which of the following particles is called particulate pollutant? So, for this, can
Fly
you
ash.
tell? Yeah, so fly ash is the correct answer. So, particulate pollutant is nothing but if any pollutant is in the form of some solid or liquid which is present in air. So, one of the example is dust, another can be smoke, fog. So, all this will result into pollution of air, which is nothing but particulate matter. Okay, so here ozone, radon, ethylene are all in different state, whereas fly ash will be in particulate matter form. Next is, which of the following salts are the main cause of temporary hardness? So can anyone let me know the various like temporary and permanent hardness, like which salts cause temporary and permanent hardness?
It's magnesium carbonate.
Yeah, so for this correct answer is magnesium carbonate. So can you differentiate between temporary and permanent hardness?
Actually, ma'am, when water is boiled,
Huh.
if it is temporary hardness, then the after boiling this water,
Huh.
carbonate compound will be
Removed.
uh,
Yeah, that
uh,
is right.
yeah, carbonate compound will be actually deposited into the bottom of the pot. But in case of other salts or other chemicals, it should not be deposited. It is very tough to separate from the water, except carbonate compound.
Yeah, so mainly like he is right. Carbonates and bicarbonates of calcium and magnesium, they are temporary. They result in temporary hardness because it can be removed by boiling. Okay, so boiling will result in the reaction that will uh, degrade the salt, or permanent hardness if you want to remove, then like if you want to result calcium sulfate to reduce, then you need some special techniques, for example lime soda process, some ion exchange resin, so that this calcium sulfate will be converted, for example, to Na2SO4. Now this will not result into hardness of water. So this requires some treatment methods. So these are nothing but sulfates or chlorides. They result in permanent hardness. Next is, find the most suitable option from the following representing the pH of rainwater.
5 to 6.
Yeah, so 5 to 6 is the correct answer. So can anyone tell me the reason, like I had mentioned in the previous slides, what can result in the such pH?
Emission of SOx and NOx gases, which react and converts the into nitrate forms, acidic form.
Yeah, so you are correct. This so there will be some SOx, NOx present, and even carbon dioxide. This results into formation of few weak acids, or like there will be formation of some acidic components, which will result into some acidity in the rainwater. Now this range is neutral. Okay, this is basic, so this two gets eliminated. Now such high concentration of acids will not be obviously present, like this is very acidic, 2 to 4. So this is like slightly acidic, it will be there. So 5 to 6 is the correct answer. Now moving forward, this is the week 1 model assignment. Which of the following option appropriately connects the oil type with API gravity range? So for this we need to know, like, the light oil will be obviously less dense as compared to medium heavy oil, as compared to heavy oil and bitumen. So this is the like least dense. Okay, this is the number of, like, moving from low density to high density. And API index or API gravity range is inversely proportional to the density of the oil, okay, or the specific gravity. So in that case, if light oil has the least specific gravity or density, then it will have maximum API. So first, for light oil it will be 42 to 27 because it is maximum. Then for medium oil it will be intermediate, which is nothing but 27 to 22. Then will come heavy oil, which is like somewhat lower to this, 22 to 10. And bitumen, since it is highly dense, it will be like this, greater than 10. Next question is, environmental engineering is the application of scientific and engineering principles to which of the following? So improve and maintain the environment, protect human health, protect nature's beneficial ecosystems.
All the above.
So all the above is the
The-
correct answer. Yeah. So by environmental engineering we do all of this. We want to maintain environment, and by that we want to maintain the ecosystem and also maintain the health of all the living organisms. Next is, identify A and B in the food chain process as shown. So I have discussed food chain many times in the class. So can you tell me what is A and B? Yes,
A
anyone?
is herbivores and B is other carnivores.
Yeah, so you are right. Herbivores, they consume the plant based uh, food. So plant is majorly consumed by herbivores, so A is herbivores. And carnivores, like if it is consumed, then it will be obviously carnivores, like animals or other than plant, whatever is there, if it is consumed, then it will come into carnivorous category. So D is the correct answer. Next question is, generally photosynthesis reaction is given as dash. Yeah, so
Carbon
what is,
dioxide, water and energy.
yeah, it will result
Producing
into
glucose
what?
and oxygen.
First one.
Yeah, okay. So first one is the balanced photosynthesis reaction, which usually occurs in plant cells. Okay, so now as the sunlight comes here, so this will be consumed by the plant cells. The CO2 from the atmosphere, H2O from the atmosphere, it will be atmosphere, or the water we provide, it will be consumed, so that CO2, H2O and this energy reacts to form glucose, and again oxygen will be released back into the atmosphere. This is why we promote more and more for growing of trees, so that it will consume more carbon dioxide, and it will result into more and more formation of oxygen. So it is always said that if you stay in some near the trees, or if trees are planted, then you will get fresh air to breathe as compared to the near environment if it is polluted. So next is, primary treatment of municipal wastewater can remove around -% solids and -% of BOD. So this was mentioned in the lecture, and it is a basic thumb rule, which is 60% and 35%. Next is, what is the full form of NOAEL?
A.
Yeah, so it is nothing but no observable adverse effect level, and which is defined as, if there is certain amount of pollutant or substance present, there will be no detectable, like you will not be able to see any adverse effects till this concentration. After this, there will be some adverse effects that can be observed, and there will be some tolerable. So here this you will not be able to observe. After this you will be able to observe, but it is still tolerable. So that is nothing but threshold, and this is like if you still go on increasing, the adverse impact will increase. Next question is, the bioaccumulation of any substance depends on dash.
D. D.
Yeah, so it depends on all, like which is rate. Okay, so if I'm exposed to something, and the if I'm exposed uh, to lead, say for example, through my skin, like it falls on my hand, then it will, the chances of skin absorbing it will, the rate at which it absorbs it will be different. And if I directly consume it through water, then the rate at which I am taking in it will be different. Okay, then mode of uptake also, if I am directly injecting, or if I am taking it through water, or if I am inhaling, so there will be some different ways it will react. And how quickly the substance is eliminated, because if you are taking in, now if it gets quickly removed from your body, then in the form of urine or excreta, then it will not be present in your body, and it will not create any adverse effect. So it is also required so that it will be quickly removed from the body. So all of the above is the correct answer. Next question is, the study of interrelationships between plants and animals that live in particular physical environment is nothing but ecology.
Ecology.
This definition we have already studied. Next is, identify the biotic component of ecosystem. So this is a very basic question. So biotic is nothing, no, air, water and soil are abiotic components, and biotic components are all the living organisms, like living organisms. So living organism here is nothing but living plants. So plant is the correct answer. Next question is, consider a solution of ammonium sulfate prepared by dissolving 54 grams of anhydrous compound in water and diluting it to 1 liter. What is the concentration of this solution in moles per liter? So basically you need to find out the molarity. Okay, here there is one catch, anhydrous compound. So what does that anhydrous compound mean?
Water content is nil.
Yeah, so if I want to say for example, if this is the compound of salt, like if this is my salt, then if I dissolve it in water, or like if it is present in crystal form, then there in some cases it is surrounded by water to form a complex. Okay, through complex coordinate covalent bond, or there will be some bond between them, between the salt and water. So if such type of compound is there, then it will be hydrated. Anhydrous means that it will not absorb water from atmosphere. So anhydrous ammonium sulfate. So ammonium sulfate has formula this. So calculate the molecular formula for this first. Sorry, the molecular weight. Everyone please calculate the molecular weight of ammonium sulfate. Do you want to tell me the molecular weight of each of these?
Yeah, yes. We forgot our chemistry.
Yeah, so for nitrogen it is 14, hydrogen it is obviously 1, sulfur
This is
it is
132.
32, and yeah, oxygen it is 16. So if you calculate, it will come out to be 132 gram per mole. So now next is the definition of molarity. So molarity is nothing but moles present per unit volume
in kg.
in liter. No, volume has to be in liters for molarity. Okay, so this is the basic definition, and here also you need to find out in moles per liter. Okay, so moles will be what? So first calculate the moles of ammonium sulfate in the solution, how much you are dissolving. So moles will be what? Grams of substance, like grams of this ammonium sulfate divided by its molecular weight. So calculate this. This will be 54 by 132. What does it come out to be? I guess 0.4 approximately. Yeah, everyone getting this? Is everyone getting this? Can someone please tell me?
0.4.
Yeah, it is coming near to 0.4, right? Please mute yourself. Yeah, so 0.4 is the amount of moles. Okay.
0.4.
Yeah, so molarity or the moles per liter of ammonium sulfate will be nothing but 0.4 moles are present in 1 liter water. Okay, so moles per liter or molarity would be 0.4 only. So correct answer is 0.4. Yeah, so this is it for today. Thank you everyone. If you have any doubt now, you can tell me.
Can you discuss the tutorial one?
I guess the assignment one is same. So can you tell me the particular question? I don't have, like, I will have
This is
to.
about that octane water.
Can you write that question or?
1 minute, ma'am. I'll just.
Yes, madam. Actually, where I can, where I can, hello,
Hello. Yeah.
where
Hello.
I can revisit your lecture again.
You can, like, a link will be shared to you where, like, I will be uploading this lecture on the YouTube, and the link for the same will be uploaded, like it will be given to you. So through that you can
By
access.
mail?
Yeah, you will receive a mail.
Okay.
Madam, can I tell you the problem?
Yeah.
If a compound X has an octane water partitioning coefficient of 130 and the concentration of X in lake water is 0.5 milligram per liter, find approximate concentration of X in the animal at the bottom of all food chains in the link. That solving part I'm not able to do, that log and all that.
Sorry, what you are not able to do?
That is, it starts with, we know that log BCF uh, is equal to 0.79 log of KOW minus 0.4. So I'm not able to solve that part. Log is logarithm to the base 10.
Yeah.
Okay, so first we need to take the log of 130
Yeah.
and then you should multiply with 0.79. What is the procedure to do it? I'm not a math student, that's why.
Okay, I will tell you. Just give me a second. Or I can share you the solution in my notes. Is that okay? I will have to calculate actually. I will calculate and share the
Because the
solution.
steps are not given. So that is why this confusion. It's just given that 0.79 log of KOW minus 0.4. So when we are putting it in, I don't know how to do
Actually,
this solving part.
sorry, I just forgot the formula, so I will have to see, and I will have to see the conversion. So that is why I told that I will upload the solution on my notes, or you can give me a few minutes. I will just check the formula, and I will uh, solve.
Yeah, bioconservation factor.
Just a second, I will check the
If there,
formula.
it's a problem 2 in tutorial 1.
Okay. So yeah, log KOW is nothing but you just have to take logarithm to the base 10. So it will be, if you have a scientific calculator, you just take log of 130, I guess it is given, right? So 100 log of 130, you multiply that with 0.79 and subtract 0.4 from it. So this will come out to be log BCF. Okay, so now to find out this BCF, you have to take anti-log of it. So that is nothing but exponential of what answer you are getting. So for me it is coming 3.56.
Ma'am, in final exam, we can carry scientific calculator.
Yeah, as per my knowledge, you can carry scientific calculator. Still I will confirm you the same.
Ma'am, BCF is coming as 18.62 liter per kilogram.
18. No, wait, it is coming to me something different. Wait, I will just do
That's the
it.
answer that's
What is it? 18 point?
62 liter per kilogram.
Okay, I am getting some different answer. Wait, I will calculate this and put the solution in the notes. This presentation will also be uploaded, and the link for the same will be shared to you. So I will upload it, and or I can discuss in the next class also. Is that okay? Yeah, sure. Any other doubt?
No, ma'am.
Is there any is the method that I am following, is it okay, or you want some change in method?
Okay, method is okay.
Method is okay.
Yeah.
Okay, thanks. Yeah, someone has raised the hand.
अपनी सास
Someone has raised the hand. Can you please unmute and tell? I guess it is by mistake. So if there is no more doubt, then I can close the session. And sorry, I will just post the handwritten answer for the question that you are saying, and I will share it to you. Okay. Okay, thank you.
Okay.
Thank you.
Thank you for joining. Thank you.
Thank you.
Thank you.
Thank you. Hello. अच्छा, ऑर्डर आया है। अच्छा, आप इस दिन के नीचे हो, मैं